Hi friends, welcome to WebChamp. In this video, I'm going to discuss threading in Python. Okay, let's understand what does mean by thread. So thread is a something, okay, which is virtual. We cannot see the thread, but yes, that is used to execute your Python program. So if you write the number of lines of code, so that will be executed by a thread. Okay, so if it is possible to divide your work, okay, let's say you are reading the data from database for couple of years. Okay, this is what the one example I'm taking. So let's say from 2016 until from 2016 to 2023. If you are reading a data and reading a data from database using ODBC connection, if that means you are using a single thread. Okay, you are using a single thread. So what you can do, you can create the multiple threads to pull the data from database for each year like this. Okay, for 2016 there will be one thread, for 2017 there will be one thread, and if I say like this for 2023 there will be one thread. So what it will does, so obviously whenever you are using a single thread to pull the data from database for those many number of years, so let's say if this takes 140 minutes, for example, it takes 140 minutes to pull the data for entire range. So if you create the separate thread to pull the data from database, so approximately it takes 20 minutes. 20 minutes, okay. And if your multiple threads work simultaneously, or we can say that work parallelly to pull the data, so each year data will be in your bucket in 20 minutes instead of 140 minutes. So this is how you can save your time definitely while reading the data. And threading is always good while reading the data. It is not good while writing the uh, data. But yes, if you are writing the data to the different files using the different threads, in that case that is good. But if you are sharing the resources, no, in that time it is hard to understand the behavior of threading. So but you are always good to read the data, you are always good to fetch the data from database using this mechanism. Okay, this is what the one example I have. So I told you. So what it means, you have to divide your load on the Python into the multiple threads. So obviously, so parallelism you have to create. So that is what the meaning of actually threading, or that is what the use of threading. So this refers to the concurrent execution of threads. So multiple tasks you can perform at the same time. That is what the thread. And thread is imaginary. Okay, we cannot see the thread. And yes, but Python provided threading module to work with thread. Now, threads are lightweight and independent units of execution within a process. Okay, so threading works on the same, meaning it shares the memory. Okay, same memory it will use for the multiple threads. Okay, so Python threading modules provide a way to create and manage the thread. So obviously, how you can create the thread? So there is a threading model, so you have to use that. And threading is particularly useful task that can be executed independently, obviously. So these threads are independent, they will execute the program independently, and allowing for the parallelism and potentially improving the overall performance of your program, meaning your computer or CPU has lots of power. We are trying to utilize that power by creating the multiple multiple threads. Okay, so as I said, Python provide the threading model to work with this. So let's see how we can create. So here I noted the steps. Okay, first you need to import the threading model, then you need to create the class, and then inherit the thread class from the threading module. Okay, then override the run method of thread class, and then instantiate new class and call start method from the start method. So use join method to join the thread with main. So these are the few basic steps you need to follow while working with thread or while creating a thread. So I have given the example also on my next slides. Okay, so here you can see that there are two ways to create the thread. So I will show you first by importing the thread. But before that, let's understand what does this mean by. Okay, so there is a package called threading. So you can say import, and if I start writing threading, so you will be able to see that. Okay, so this is what the threading is, a module. You can see here it is module, meaning this is .py file. Inside of that py file, there is a class called a thread. So I'm just writing the definition in this way that is there. Okay, so there is a class called, I will say, threading dot. Okay, you can see thread. Okay, so this is how there is a one class. I'm just trying to create the class, but actually I could not write. Okay, so somewhere I will write, but here if I use the notepad, okay, it is better to do that. So there is one class inside a threading module. That class is called thread. Okay, so this is how the definition. This class is abstract, meaning there is no defined, no body is defined for the method. So this class has two methods. One is run method, another one is start method. Okay, this is what the start method. And this start method is not actually abstract. Okay, this method is calling the run method of thread class. So I will just consider this is as a thread class. So I will say thread dot run. So this method is called from start method. So but whatever, this method is abstract method. So I can say here at it's like, okay, just consider abstract. So this is how the definition is already there in Python, and obviously this method is not implemented. So we have to implement this. We have to write the code for this run method in our class. So if we create any class, we are going to inherit this thread class, right? And then it is possible to override. So we are going to override this, meaning we are going to implement the run method in our program. Whatever the task you would like to perform, so you can write that into this run method. Okay, and like this you can create n number of classes. Okay, so if I create class and if I say thread, okay, instead of that I will say my thread one. Okay, this is just an example I will show you. So my class one, and here you have to define the run method. Obviously you are going to, and self is a parameter obviously that is required for the object, because we are going to instantiate this class. So this is what the definition. And if I write the print statement, I'm just writing print statement. This is thread one. Okay, so this is what my implementation. So far I'm not going to implement details, but yes, if you want to do the connection with database and read the data, you can read the data, bring the data into your one of the variables, store the data inside one of the class variable, and then you can append. So obviously we will see that part also in my next coming videos. I will discuss that how to use the multi-threading to pull the data from database. So okay, on that time, so you will be able to feel what is the actual use of this. Okay, so that will be the real-time example of this threading. So here I will say thread dot. So okay, so run method is remain same for n number of classes, and I will say then 3, then 4. Okay, this is again 3. So like this you can create any number of threads. Okay, but you see, by writing this is not sufficient. Okay, so you have implemented run method, but you have not inherited. So you need to achieve the inheritance also, otherwise you will not be able to, you will not be able to run this run method, meaning you will not be able to execute, because you have to execute this run method through the start method only. Okay, and the start method will be called by the object of each class. Okay, so this is what the inheritance. Now this thread method, sorry, this thread class has run method, which is abstract. Okay, so we have implemented that method here. So any logic you can implement it here as per your requirement. Inside a run method, you can decide how many threads you want to create. Now next is, okay, so you need to instantiate this class. So I will say t1 is equal to my thread 1. Okay, so this is what my first thread 1, t2, t3, t4. Okay, and I'm going to change the names also, 2, 3, because this is how you need to instantiate the your classes. Okay, once this class is instantiated, now you are able to call the start method. So you can see that we have not implemented the start method here in our class, but still you are able to call the method, right? And if I say this, because internally the start method is going to call your run method. So I will say 2, 3, 4. Okay, so this is how you have to call this methods. Now I will call these methods. Okay, obviously, but what will happen after that? I will say print. So I just wanted to show you the difference. Okay, this is main thread. So what will happen? Okay, so whenever you create, see, this start method will create one thread and it will start the execution of your code, whatever the code you have written inside this run method of each class. Okay, and after starting the new threads, obviously main method is not going to wait for those threads, so it will go and it will execute this statement immediately. Even this entire operation is very very much faster. You sometimes you may see the output of this, but let's say these are just time taking processes, so main thread will go ahead and execute. So we will try that also. So now if I run this, okay, so if I say py webjump.py, if I run this, okay, so here you can see that thread 1, 2, 3, 4, before executing the main thread last statement, what is happening? So all the threads are getting executed. So now what we will do, we will add some time. So let's import. Okay, so waiting time we will add, let's say time, and I will just give the time dot, okay, sleep. So this will wait for 5 seconds is sufficient. Okay, and we don't know how much time each thread will take to get finish the execution. So everywhere I will say 5 seconds, 6 seconds. Okay, this is how. So now you can see that main thread will not wait to finish all these threads execution. It will go ahead and execute this last statement. Okay, so main thread will continue its work. So that's why what I am doing is I'm just adding a time, because this is, as I said, na, this is very, very faster process. So if I say 5 and if I say 4, okay, so you can see that now as soon as, consider that this thread execution, this first run method execution got finished in 5 seconds, then this got finished in 6 seconds, then this got finished in 5 seconds, then this got finished in 4 seconds. So this is how threadings are used. Now if I run this, you can see that main thread is finished. Now thread 4 is, then thread 1 is, then thread 3 is, and then thread 2 is. Okay, so it's completely depends upon thread execution. Finishing time is obviously completely depends upon your complete depends upon your process and how long that specific thread takes to get finished, right? So this is how the threading works. Okay, so let me reduce this. Okay, fine. So now what we will do, we will keep main thread waiting. Okay, so what is my expectation is, okay, until all these sub threads execution gets finished, my main thread should not go ahead and execute the further code. But this is what my expectation. So in that case, what we can do, we can simply say t1 dot join. Okay, so join is the method that is used to keep the main thread on waiting until the execution of this sub thread. So meaning thread 1, 2, 3, 4 gets finished. Okay, so now you can see that t4 dot, right. So earlier what output we have seen, that this is the main thread. So that got printed first, meaning that is executed first, and later the threads are executed. Okay, so now you can see that main thread will wait. Okay, I think I forgot to save this file. Okay, so and if you do not save your work, it is not going to work. So now if I run this, you can see that it is not printing. I have executed the code, but it is not printing the this is main thread. Okay, so this is main thread is printed at the end. Why? Because I just used a join method, and join, what join method does, so wait until the thread terminates. Okay, so whatever the okay, so main thread has to wait until the t1 get terminated, t2 did get meaning thread 2 terminated, t3 gets terminated, t4 gets terminated. Okay, and this is how it going to works. Okay, so why you need to use the join method? So obviously, let's say you have to, let's say all these threads are bringing up the data from database. Okay, and you have to use this data together for the further processing. Okay, for the further processing, because you cannot use each thread to write the data into the single file. Same resources they cannot share at the same time. That is that is a problem. You can read the data, but you cannot write the data using multiple threads to the single resources. Okay, if you wanted to write the data into the different files, then that is possible. Okay, then there will not be any problem. Each thread will create a new file, and then they will write the data into the specific file. That is fine. But let's say you have to write the data into the same file. That is not possible. So in that case, we need to keep the main thread on waiting, and we need to collect all this our threads data into the single variable, and then we can store that data somewhere. Meaning it's completely depends upon the operations how you wants to perform. So this is how this kind of these operations are going to work. So threading is useful while reading the data, and this is the one way to create the threading. Whatever we have seen is just one way. Another way is that you can define your own function. Okay, so I'm just going to remove everything from this, and what you can do, you can define your own function. So instead of you creating the class and all, so what you can do, you can define your own functions. So if I say I will remove this, okay, and I will use this code as a function one. Okay, and without creating a class, how we can create the threads, that is what we are going to see. Okay, let me, and this I will change the name of this functions later. Let me structure it first, because Python works on indentation, so we cannot leave the code as we want or as it is. Okay, so we need to organize this code, and then it is possible. So here I will say thread one. Okay, or I can say my thread one. Okay, so my thread one. Then I will say here my thread two. Okay, so here we don't need to pass this variables, meaning this name itself, a parameter called self, because this is not a method of class now. So I will say my thread re and my thread 4. Okay, so this is how I have created a 4 method for now. These are the normal functions. Okay, these are the functions, not a functions of, or not a methods of, not a functions of any class. Okay, so now what we can do is we can use this function, pass these functions. Okay, let's say I wanted to create a thread 1. So I will say T1 is equal to threading dot thread, and this is what the constructor we can use. And then here what we can do is we can pass the target method. So here you can see the target is object, so obviously here I will pass my thread 1. Okay, target function I'm passing. Okay, and I think I need to write the target there. Okay, obviously it's because this accepts the parameters in the form of key and value pair, so you need to write this. So this will create your thread. Okay, this will create your thread, and this variable you can use to start and join. So now even here also, so if I say start, okay, so you don't need to write run method also. So this is another way to do that. And I can say, okay, not t2, if I say t1 dot join. Okay, so join is used, you are very much familiar with this join method now. Okay, so this is how you can create some, let's say I wanted to create the 4 threads. So if I say this, then this, then this, again same I will do here also, 2, 3 and 4. Okay, so this is how I can do, right? And now T1 we have initialized until you start, and until you start the threads are not going to start. Okay, so you need to say everywhere as a T2, T2, okay, not T3. So this is T2, then this is T3, this is T4. So all 4 threads I'm going to start, and I'm asking main thread to wait. Okay, so main thread should not go ahead and execute the further code until the all the threads execution gets finished. Okay, it is not necessary. Okay, in your case, if it is not required to keep waiting main thread for other threads execution, then you can go ahead and you do not need to use this join method. Okay. So now if I run this same output, we will see. So behavior will remain same, thread 1, 2, 3, 4, whatever will be there. So it will behave. So thread 1 got finished first. Okay, you can see that. The thread 2 got finished first. Okay, thread 2, 3. Okay, the problem is what we have not started all the threads at the time. So what we did is, here I used t1 dot join. That's why it got executed in the same sequence. So it was in on making. So what I will do, I will keep join methods down of this, so that it should not wait for each thread. Okay, so this is what I missed to follow here. So I wanted to start all those threads at the same time, right? So what I can do, I can use all the start method first, and then I will keep this after the, meaning I will use the join method after the all the start methods. Okay, so now the output will be different. Okay, okay, so now you can see that we are getting the appropriate output, and in this is 4, 3, 2, 1. Okay, so we can't predict which thread will get executed first. Okay, so that is not in our hand. If I give the time, okay, so same time for all the threads, you will be able to see that every time we will, okay, it's not like that every time, but yes, so we can get the different sequence of execution. If I run this, so this is saved. Okay, so here now I'm getting 2, 1, 4, 3. Okay, if I run once again, So this sequence can change, so that we may get the same sequence, we may get a different sequence. So here you can say that first thread, second thread, fourth thread. Okay, so now if I run this, so 3 trials we are doing. Here we got different ways of output, meaning different sequence of thread is execution finished. Here we are getting different, here we are getting different, right? So thread execution, which thread will get started first, we cannot control that. Okay, that is completely depends on the task scheduler or thread scheduler in Python. So that is different part. Okay, so we need not to worry about that. But yes, in fraction of seconds all the threads will get started. Okay, so this is how threading works in a Python, and you can use threading to perform the various kinds of operations at the same time, or if you want to do multiple tasks at the same time. So obviously you can save your time, you can use the power of your CPU using multi-threading. Okay, so I hope you like the content of this video. Thank you so much for watching the video. Have a nice day. Do not forget to subscribe WebChamp and be stick to the WebChamp. In my next video, I will show you how we can use threadings to read the data from database using threading. Okay.